Okay guys, I wanted to go through this little graphic organizer as a brief note, kind of to help you study for the next assessment that we're doing. Let's pull back a little here and look at it all at once. So it sort of highlights what the big three forms are for quadratics. So form 1 would be standard, form 2 would be vertex, and then 3 would be this factored form. And it's not like number 1, number 2, number 3. They just happen to be the three forms of them. So things that you might notice when you're looking at these three all at the same time would be that they all contain this A right here. So all forms share the A term, which highlights the vertical, stretch, or compression. So it's going to be the thing that makes our quadratic really tall and skinny, or it might possibly make it really wide, something like that. It can also flip it over, which is actually like more of a reflection than a stretch compression, but it still would be the A term that would do that. So it might just flip it over. So this would be something like A equals -1, some kind of negative number. This would be A equals 1/3, something like that. These ones that are wide like this are where A is less than or equal to 1 but greater than or equal to 0. And then if it also happened to be negative, it would be wide but flipped over. And then this one right here, let's imagine that it's narrower than a normal one. This would be where A is greater than our normal 1. So greater than 1 is our normal parent function. So it's going to be getting skinnier as this number gets larger. Okay, let's go through the three forms. So standard form, it's not really good for anything. It highlights like one thing. It highlights the y-intercept, which is C. And the reason that happens is because f of 0 is where the y-intercept is. So if I plug 0 in for every x, the first term's going to become 0. The second term's going to become 0, and we're going to be left with whatever C is. So this term right here will always be our y-intercept. Otherwise, not really a whole lot going on there. Visually, doesn't really highlight anything in particular, except for, let's say it's something like this, then this would be the point 0, C. Let's go down here to factored form. So if I wanted to go from standard form to factored form, I'm going to factor using the flow chart. We had a video on that the other day, so using the AC method or pulling out the greatest common factor, or there's always the possibility that it's not factorable at all. So always be aware that it's possible, it's not factorable. Okay, so factored form is going to be A times x minus r, x minus s. This A term isn't always pulled out when we factor. For example, we might have something like 3x minus 2 times 2x plus 4. So that might be an example where the A hasn't been pulled out. It's fine. It's still considered factored form. You just want to be aware that the A term here out front would have to be pulled out of each of these terms independently and then multiplied together. So for example, if I were to pull out the 3, that would give me x minus 2/3, and pull out the 2, that would give me x plus 2, and I would multiply those two together to get 6. So it's a little bit messy when it's got the a multiplied back into the function, but it's fine. It doesn't really make a big difference in terms of what this form highlights. So what it's going to show, or the easiest thing to see from this, is it highlights our X-intercepts. So our X-intercepts are when y equals 0. So we're going to look at this example right here. So we want to know, what does x have to be to make y equals 0? Well, there's a couple of ways to think about it. If I have two numbers, remember this whole quantity, it represents one number. This whole quantity represents another number. And if I have two numbers that are multiplying together, the answer is 0. Either this number is 0, or this number is 0, or they're both 0. So we're going to break this up into two equations and solve for x to figure out x would have to be what term in order to make the output 0. So 3x minus 2 equals 0, or slash and 2x plus 4 equals 0. So x here would have to be 2/3 by shifting the 2 over and dividing out our 3. And then here x would have to be 2 by shifting our 4 over, -2. Makes -4 dividing by 2 makes -2. So visually what that would look like is that from our factored form we would solve for our x-intercepts, which would be at, let's put 1 there, 1, -1, -2, 1, 2. So 2/3 would be 2/3 comma 0 as the output, and then -2 comma 0. And then our vertex is going to be kind of in the middle between those. So we're just going to make sort of a sketch of that guy. If you wanted to check what your what your y-intercept would be, you can always take the last term here multiplied by the last term here, and you would get your y-intercept. So -2 times +4 is going to give you -8. So this term down here would have to be -8 if you wanted to highlight that. Going from factored form to vertex form, not super friendly. If you happen to be looking at a graph and you knew what your vertex was just from looking at your graph, you could plug it right into the equation. But if you don't have the graph and you only have factored form, it doesn't always make sense to complete this, to go from this jump to here. We would go back, multiply out, and then go to vertex form. Or if when you look at the video on how to go back and forth between here to here, there's some different strategies we can take, which we'll review later. But for now, we're just going to say, how do I go from standard to vertex, which is what we've been working on for the last couple weeks, which is completing the square, and I'll do that in our next video also, sort of an example of what we've been doing. What does it highlight? Well, vertex form highlights the vertex. Remember, mathematicians not creative with naming. So vertex form highlights the vertex. So the vertex will be the point h comma k, and then A will affect how steep or wide or opens up or opens down in terms of our vertex, or in terms of the rest of our quadratic. So let's imagine I'm looking at A. Let's let A be 9. Y equals 9 times x minus 2 squared plus 3. So visually what this is going to look like is, here's the tricky part, h is always the vertex, the x coordinate of the vertex is always going to be the opposite of this number. That's why it's minus h here. So minus the actual term is going to be +2. So this is always the opposite of what it is. So our vertex is going to be at 2, and k is exactly what you would think it would be. K is going to be 3. So my vertex is at 2, 3. It's going to open upwards and be really steep because we've got that 9. Okay, and then we could calculate out the y-intercept by multiplying everything out if we wanted to. Our vertex at 2, 3, that's that point down there. If you were having to look for factored form and you had been given this equation, I could recognize from this and the picture of this that there are no factors that are real. That is because it does not across the x-axis. We'll be looking at imaginary solutions a little bit later, but for now, there's no real solutions to y equals 0. What does x have to be? So this is always going to be the point HK from our vertex form. So if ever you're wondering which way to go to find the vertex, find factored form, or find standard, you can always come back and reference this little cheat sheet.